Okay, let's have a look at the proofs for homework 11, due in class Tuesday, April 17th. Alright, on this one, remember there are two basic strategies for doing proofs. There's the stumbling forward blindly approach, and then there's the working backwards from the conclusion. This one, you'll need to work back from the conclusion. Okay, so the conclusion is E. So you think to yourself, how am I going to get E? Well, it only shows up in one of the premises here. And what you notice is that it is part of a disjunction. So if you know your rules, you know that if you have something like this, something or E, if you want to end up with E, you're going to have to do it by disjunctive syllogism, and you're going to have the opposite. You're going to have the negation of this other thing. So what that tells us is we're going to need the negation of this. Okay, so we're going to need, in order to get E, we're going to have to first get this. Okay, now how are we going to get this? Well, one thing you should notice is that this is equivalent to something by De Morgan's law. Specifically, it's equivalent to not A and not D by De Morgan's law. So if you can get this, you can turn it into this. So as you can see, we're working backwards from the conclusion. We want to get E. In order to get E, we need this. In order to get this, we need this. In order to get this, we can get each of them separately and then join them together using conjunction. So how are we going to get not A? Well, notice that A only, we're not going to get it out of here because we're going to create this in order to get E. So we're not going to do anything to this before that. So the only place we could possibly get A is here. So we think to ourselves, okay, we have if A then B, and we want to end up with not A. Is there a rule that does that? And yes, there is. It's modus tollens. And in order to do modus tollens, the other premise we need is the denial of the consequent. That's what modus tollens is. So we need to get not B. So, again, working backwards from the conclusion. We want to get E. In order to get E, we need this. In order to get this, we need both of these. And in order to get this one, we need not B. How can we get not B? Well, very easily out of this. Think a person's name for a rule of equivalence. And we're also going to need that not D, and it shows up here. So if you think to yourself, okay, what is the rule that has this as one premise and ends up with this? And what is that rule, and what is the other premise that I need? And you will notice that this other premise you can also get out of line 3. All right, I've basically given the whole of that one away, so hope you're happy. All right, this one, there are two ways to go about it. One way is to do a series of hypothetical syllogisms. One thing to remember is you can't combine them all. You can't do hypothetical syllogism with a bunch of lines, like 3, 4, 5. You can't do that. You have to do hypothetical syllogisms in pairs, because it's a syllogism, so it can only have two premises. You'll see what I mean if you try that approach. But in order to, what you'll notice is that you want to get this, and you have the antecedent of it up here, and then you have the consequent of it down here. And then you have a sort of string of intermediaries here that you're going to have to alter in various ways by rules of equivalence. So for example, you notice you have H and I here, and you have H and I here, and also these are both consequent, so you're going to have to turn one into an antecedent by applying the rule that flips the order of a conditional, if you can remember what that one is and what else is involved. But also, this is a conditional and this is an ampersand. Well, there is a rule that converts between conditional and ampersand, and it's my favorite rule of equivalence. Also, you should notice that you have this, and they're not quite the same, but there is a rule of equivalence that converts between them. And also, this is not quite the same as this, but they've got the same letters and you can convert between them. So you can either do these as a series of hypothetical syllogisms, or you can apply what we learned last class, which is conditional proof, which involves starting by assuming the antecedent. So you would start indent, which you always do when you assume G, and then you can immediately do modus ponens, 1, 5, and you're off and running. And then you convert that into something, and you can do something with it here, and so on. And then make sure that your last indented line, say on line 15, is Z, and then you go back to the real world and you proved if G, then Z by conditional proof. First, the line with G on it, which is 5, through the line with Z on it, which is 15. That would be another way to do that. Okay, question 3. This one is definitely easier with conditional proof. I mentioned 2 ways to go about this. You can either try to prove the thing that is equivalent to this by exportation, which is P and M, then L, in which case you would assume P and M. And then down here, let's say on line 15, you get L, and then you will have proved if P and M, then L by conditional proof 4 through 15. 15 is just a made-up number. Don't assume it has to be that. Which isn't quite that, but then you have to convert that into this by my second favorite rule of equivalence. So that's one way, or you can do the more adventurous way, which involves 2 nested conditional proofs. So you assume P, then you assume M, and remember you double indent. This one is Narnia, this one is Wonderland. Then you try and get L down here, say on line 11, and then you go out 1, and you've proved M through L, if M then L by conditional proof 5 through 11, and then you go back out here and you've proved if P, then if M then L by conditional proof 4 through 12. So this one is contained within this one. So that's 2 ways to go about that. This one, here's my suggestion to, oops, touch the lamp, and no genie came out. One thing I would start by doing, I don't think assuming is going to help you much in this one, but do a lot of simplification. So do simplification on line 4, get both sides, and then do simplification on line 2, get both sides, and then see what that gets you. The other thing is, notice that you can get S immediately, and then you can do something to S to get this, and you can do modus ponens with this. And also you can use S when you simplify this. Try that. If you get stuck, you can always, at any point, suppose you do a bunch of stuff and you still haven't got X. Well, say on line 10, you can assume not X and then try and get a contradiction. Remember, that's reductio ad absurdum. So you would assume for reductio ad absurdum, and then you would try and get a contradiction. So suppose you have, I don't know, you have not R at, suppose you got not R up here and you get R somehow down here, then maybe on line, 13 or something, you will get R and not R. So any contradiction, something and not that something, and you would get that by conjunction. And then as soon as you got a conjunction, you go back, a contradiction, you go back to the real world, and you've proved whatever it was you denied on line 10 by conditional proof, all the indented lines. So that would be something to do if you get stuck, if somehow you can't get X without assuming anything. All right, that's all the hints you get. I will see you in class with these proofs.